A box contains 4 red pens and 5 green pens. A pen is picked at random from the box without replacement, and the second pen is picked. Grace and peace to you, and welcome back to my channel. This is Donald Siame, author of Hidden Mathematical Genius Within Revealed. This is my second video on probability. Okay, so here we have a question. We are told that there are 4 red pens and 5 green pens in a box, and the box is picked at random without replacement, and a second pen is picked. Okay, so draw a tree diagram to illustrate the outcomes. So we're going to have we have the first pick. So in the first pick, the probabilities are as follows. We have red and green. So we have 4 red, so we are going to have 4 over, the total is 4 plus 5, that is 9. So we have 4 over 9. Then for green, we have 5, so it's 5 over 9. That is in the first pick. In the second pick, the first one here will say we picked red at first, so the probabilities in the second pick will be as follows. So again we have red and green. So here we assume that we picked red, so red now becomes 3, and the total will be 8. So we are going to have 3 over 8. Green will maintain as 5, then the total 8, so we have 5 over 8. Okay, the next here we'll assume that we picked green. So if we picked green, the probabilities are as follows. So again we have red and green. So if we picked green in the first pick, it means red is still 4. Then the total will be green is 4, so 4 plus 4, that is 8. So it will be 4 over 8. And if you simplify the fraction, it will be 1 over 2. So we have 1 over 2. Okay, for green here, we are going to have green is 4 and total is 8. So again, if you simplify the fraction, it will be 1 over 2. So this is the tree diagram. Then we go to the second question. Second question, what is the probability of picking 1 red pen and 1 green pen? Okay, 1 red pen and 1 green pen. So probability of picking 1 red pen and 1 green will be, so here the outcomes. The outcomes are going to have red, then we have red, green, and this is green, red, and red, this is green, green. So probability of picking 1 red and 1 green would be, we can have P of red, green, or P of green, red. Okay, so in probability, O means addition and means multiplication. So here is red, so we have red and green. Red and green, the two probabilities will multiply. So red and green, that is 4 over 9 times 5 over 8. So it's 4 over 9 times 5 over 8. That is for red, green. Red and green. Then you can also have green and red. So plus, for green and red, green, green here, we have 5 over 9 times red is 1 over 2. Okay, so we work them out. So we have, this is 4 in 8, that is 2. So 4 in 4 is 1. In 8, that is 2. Okay, so we are going to have 1 multiplied by 5, that is 5. over 18 plus that one there is 5 again over 2 multiplied by 9 multiplied by 2, you get 18. So there we have same denominator, so you can just add the numerators. So we are going to have 5 plus 5 is 10, so it's 10 over 18. So when you simplify that fraction, the highest common factor for 10 and 18 is 2. So 2 in 10 is 5, and 2 in 18 is 9. So we have 5 over 9. So that's how you perform calculations. Okay, we'll go to the second question. So second question, 13 cubes of the same size are numbered 1 to 13 are placed in a bag. If 2 cubes are drawn at random from the bag, one after another, and not replaced, what is the probability that both cubes are odd numbered? Okay, so first thing, let's do a tree diagram. So this tree diagram has two types of numbers. We have odd numbers and even numbers. Okay, so we have our first trial there, or first pick. We're supposed to have odd numbers, let's put all there, and even numbers. So how many odd numbers from 1 to 13? So we know that 1 is odd number, 3, 5, 7, 9, 11, and 13. So we have 1, 2, 3, 4, 5, 6, 7. So we have 7 odd numbers. So we are going to have 7 over 13. Then even numbers will be 6. That is 2, 4, 6, 8, 10, 12. So we have 6. So even numbers we have 6 over 13. Okay, so in the second pick, we have, so here odd number again and even number. So here we assume that we picked an odd number. So here odd numbers will be 6 in the second pick. So it will be 6 over 12. And if you simplify 6 over 12, you get 1 over 2. Okay, so even numbers will maintain to be 6. So 6 over 12 again, simplified to be 1 over 2. Okay, then next here we assume that we picked an even number. So we have odd number and even number. So you assume that the odd number is maintained. That will be 7. So it's 7 over 12. Then even numbers will be 5, since we picked an even number in the first trial. So we are going to have 5 over 12. Okay, so what is the question? Okay, what is the probability that both cubes are odd numbered? So we have the possible outcomes. We have OO, OE, EO, and EE. So we want to find the probability that both cubes are odd numbered. So we want to solve for P of OO. That is odd and odd. So the first odd number, the probability there is 7 over 13 times the second one is 1 over 2. So you multiply the two fractions. So it will be 7 multiplied by 1 is 7 over 13 multiplied by 2, you get 26. So it's 7 over 26. Okay, next question. What is the probability that only one is even numbered? Only one is even numbered. So if only one is even numbered, it means we can have P of OE, that is odd and even number, or P of even and odd. So P of OE, that should be O, odd number is 7 over 13. So we have 7 over 13 times even number there is 1 over 2, plus even number there is 6 over 13, times odd number there is 7 over 12. Okay, so this will be 7 times 1, you get 7, that is 7 over 26, plus here we'll say this is 6 in 12 is 2, so 6 in 6 is 1, in 12 that is 2, so we have 1 times 7 is 7 over 13 multiplied by 2, that is 26. Again here we have same denominator, so you can just add the numerators. What is 7 plus 7? That is 14 over 26. Then we can simplify the fraction. Okay, what is the highest common factor for 14 and 26? Yes, 2. 2 in 14, that is 7, and 2 in 26, that is 13. So we have 7 over 13. So this is how you perform calculations to do with probability with regards to tree diagrams. Thank you so much for your time.